is to protect a worker's hands from hazards at work, including sharp objects. Protection needs vary according to the job or application. For example, packaging and warehousing workers usually need light cut protection when working with blades or knives. On the other hand, glass manufacturing and metal fabrication demand heavy-duty cut protection. The level of cut protection that a work glove can provide is determined by the type of fibers in the shell or liner of the glove and the thickness or weight of the material. What's the key? Matching the right level of cut protection to the job. There are two standards that can help guide you in this decision. In the US, the preferred standard is the ANSI 105 for hand protection classification, developed by the International Safety Equipment Association, or ISEA. The ANSI standards are about comprehensive hand protection. ANSI 105-2016 rates cut resistance on a scale of A1 to A9, where A1 is the lowest level and A9 is the highest level of cut protection. To test, a swatch fabric is cut from the palm of the glove and placed on a TDM 100 machine. This is the machine that is referenced in the standard for testing gloves. The machine then runs a straight-edge razor blade across the fabric. The blade is attached to a weight at the top and measures the pressure applied in grams. The weight continues to be increased, adding pressure to the blade until it finally cuts through the fabric. As you can see from this chart, the A1 through A9 ratings are assigned based on how many grams of pressure are needed to cut the fabric. These are called gram scores. There are at least 3 passes of the blade at every weight, and these are averaged to get the final gram score. What's the difference between the new and the old, or the pre-2016 ANSI scores? There are now 9 cut levels instead of 5. Previously, level 4 was very broad, ranging from 1,500 to 3,499 grams. Now 3 levels have replaced level 4 to provide more granularity. In addition, the old scores maxed out at 3,500 grams. Now the upper levels have been expanded, and the new maximum score is 6,000 plus grams. This increased gradation helps make distinctions in protection that previously didn't exist, so you can make a more informed decision. Europe and other countries around the world rely on the EN 388 standard. The EN 388 standard uses 2 different methods when measuring the cut level of gloves: the cutt test and the EN 13997 test using the TDM 100 machine. When testing to the cutt test, the material is placed beneath a rotating blade under a fixed weight, resulting in a cut score ranging from 1 to 5. Using the same TDM 100 machine for ANSI testing, the ISO 13997 is used to give more accurate scores for higher cut-resistant materials. The cutt test is still used for lower cut resistance materials, but if the cutt test results in a level ranging from 3 to 5, the ISO 13997 test is required. The ISO test will result in a score measured in newtons from A to F. Here's a chart to help you better understand how the scores correlate to the markings. As you take into consideration the level of resistance needed for protection in various applications, remember, not every job requires a high cut score. Here at PIP, we have the broadest range of cut gloves offered in the US. We are constantly researching engineered yarns and new materials to bring you improved